welcome to chapter 11. We're going to start with the meaning of volume, but chapter 11 is all about volume. So if you open your textbooks to page 459, you'll see pictures of tomatoes, and they are talking about packaging them and how if you are a tomato distributor, if you're a farmer and you sell your tomatoes somewhere, how you package them so that you can carry the most tomatoes without damaging them. Also, if you distribute tomato juice, how much juice fits in a cylinder style can, those kind of things. So volume is really important in the business world. It's also something that you need to learn for other things. The connection that your book makes to the Bible is talking about bearing fruit, like tomatoes are a fruit, even though we like to think of them more with vegetables. But like natural fruits, we are attached by a vine to other Christians, and we depend on God. We have fruits of the Spirit, right? And we're the branches of the true vine. So just as a reminder that fruit isn't meant to be just a plant, it's meant to be studied, and we learn about volume in this section. I just think it's kind of a funny connection to fruits of the Spirit. But that's in Galatians 5:22 through 23. I know the Math Funny had nothing to do with volume, but I'm running out of unique ones, so hopefully you thought that was kind of funny. As a math major, I found it hilarious, of course. Okay, so definition of volume. The volume of a solid is the number of cubic units needed to fill up the interior completely. So in chapter 8 we talked about surface area of solids, and now we're going to talk about the interior of the solid. So these are three-dimensional figures, and everything is in cubic units. So units with a to the third power is how we'll write that a lot, unless we have an actual unit like centimeters, meters, etc. So here is a three-dimensional figure where I have a cubic unit, and I'm going to see how many cubic units fill up the interior of this three-dimensional solid. And when I count them all up, I will be able to know exactly how many cubic units fills the interior of this three-dimensional figure. The volume postulate says that every solid has a volume given by a positive real number. We cannot have negative area. We can also not have negative volume. The congruent solids postulate says that congruent solids have the same volume. Much like congruent areas, there's lots of similarities here to volume and area postulates. So here's our first formula. We are going to be inundated with formulas like we were for area, but now with volume. So the volume of a cube postulate says that you literally just take the length of one edge and you cube it. So here is a picture of my favorite cube, but if I know the length of that, which let's just say it's 3 units long, 3 to the third power is 27. So 3 times 3 times 3. That would be the volume of this cube. The volume addition postulate says the interiors of the two solids do not intersect, then the volume of their union is the sum of the volumes. Excuse me. So if I have a very crazy shaped figure, I can divide it up into sections and figure the volumes out according to the formulas that I have, and then add them all together. So here's our second equation, the volume of a rectangular prism. So just a reminder of what a rectangular prism looks like. I always remind myself of the Kleenex box. Okay, so it has rectangular bases, it has rectangular faces, it's an elongated cube. Okay, So we're going to multiply the length times the width times the height, and then we will have the volume of our rectangular prism. And that is all for this first section. Hopefully you're not finding it too difficult. I have 3 practice problems for you, and so if you'll email me your work and your answers and then grade those before class, I will see you then.